Okay, ready, set, and here I go. Talking about the homework from last time. So, problem number 1, it asks what the mode is. It looks like the mode is the number 14. Excuse me. That is the most occurring number, right? Make sure your cell phones are away, please. The median, that's the middle number, so they're already lined up in numerical order. You just need to find the middle. The middle happens to be 14. And then the average, you add all the numbers up and divide by the total number of numbers that are on the list, and it looks like we get 15. So remember, the mode is like mu sub 0. The median is x hat, and then x, what is the mean? X line or x bar. Okay. The shape of the distribution, anyone figured out? Is there a particular shape? Skew right or left? What do you think? Looks right? Yeah. Yep. So if you made your histogram, it tails off more to the right, so it's skewed right. If it's skewed right, what is moved to the right, the median or the mean? Mean. Okay, so the mean is influenced by outliers, and outliers are what skew things right and left. Okay? If a score of 35 was added to the test, which statistics would be changed drastically? If I have a number 35 to the list, is 35 a larger number than our list or a smaller number right in the mix? Yeah, larger. Is it a lot larger, seem like? So what would move, the mean or the median? Or the mode? The mean would move because of that. Okay, in the past 10 games, the Nuggets scored those points. So the average is 96.3, so the mean 96.3. The median is 97, that's the middle of the numbers. And the mode, the most occurring number, is 97. When you're doing these and trying to find the median, your calculator is going to do a lot for you if you know how to utilize it. And someone asked if I could go back through that today, and I absolutely will. Answer true or false. So number 7, the mean is not resistant to the measure of the center. It is not resistant of the measure in the center. Hey, how you doing? Thank you very low. Perfect. Another one. She not there. All right. Yeah, I speak English well. Data that are skewed left will likely result in a lower mean than the median. The skewed left, what moved? The mean. So is the mean going to be a lower value then? Yep, so that's true. Number 9, the mode works really well in continuous data. That's false. When the data is skewed right, the mode will be the highest measure of tendency. No, that would be the mean. That would be the highest measure of tendency of the skewed right. Half the data must be above the mean and half must be below the mean. That's false. What's half the data above? The median. That's the middle of your data, and half is below it. And then in uniform distribution, the mean, median, mode are all the same value. That would be false. The mode doesn't necessarily be influenced by that. If the data, if everything is the exact same value, if you had a number of things, if you had like 9 9s, 9 10s, 9 11s, 9 12s, there's not a mode to it. Everything is the same. So the mode isn't going to be influenced by that. If the data are skewed, then the median is more useful as the center. That's true. That's Henry. Right? Perfect. That is you. It's the white paper. Okay. All right, identify the shape of each data. So if you plug this in, number 14 is relatively uniform. Number 15 is symmetric. And when I say uniform, it means that if on your histogram, all the bars are the same size. Number 15 is relatively symmetric. Number 16, you would have values to the left, so it's skewed left. Number 17 is called bimodal. There's 2 modes to the same occurring number. So 2 and 6 are the same amount of time. And number 18 is skewed to the right. And then identify each, let's see. So we want to describe it as discrete, continuous, or categorical. Remember, if it's discrete, it's a whole number. If it's continuous, you have fractions or decimals involved. If it's categorical, that means you're giving it a label, not a numeric value. So shoe size would be continuous. Okay, the reason I would say it would be continuous, though you might have a 5 and a 5.5 and a 6, you do have fractions in there, but your true shoe size, you wear the shoe that is closest to the right fit of your foot. So if you think about it, if you were to measure your foot and measure everybody's foot in the whole world, just because you have a 5.5 foot or a 7.5 foot or whatever, doesn't mean the person with also a 7.5 size shoe has the exact same length of foot as you. You have millimeters off. So I would say shoe size should be continuous. Height could be continuous because not everyone, even though you're 5'9", you might be a smidge above or below it. Gender, what do you think gender is? It's a category. Yeah. GPA, continuous. We can have a 3.456 GPA, or like I had in high school, a 0.003. I passed Latin with a D. Failed everything else. It's all right. No, I mean high school. I'm just kidding. I didn't fail everything else. I only failed like 3 things. Yeah, that's shoot. They let anyone do it. So number of cars in the west parking lot. It's discrete. Okay, you have an actual numerical number of cars. You don't have 14.5 cars out there. God bless you. God bless you. Temperature outside is continuous. Number of text messages in a day. Discrete. Type of car. Category. And eye color. And then 20, 29, I think you could generate those. Are there any of those that you would like to see? Or is there any of those you'd like to see where we're using the calculator? Okay, I know that the calculator is a newer concept for some. What do you got?
Just a question. For number 3, you got 15 yet? No.
Number 3, I got a mean of 15. Perfect. We good to go?
Shoot.
Can we move on?
Shoot.
Shooting what? Give me basketball. I'll show you how bad I can shoot. It's pretty bad. All right. Moving on section 3.3, there's a lot of stuff, again, that some of this is going to look familiar, then we're going to add a little bit to it. If we talk about the range of a group of numbers, you're taking the highest number and you're subtracting from the lowest number, and that's the range. That's pretty easy to think about. Okay? And then if we were to use the numbers 1, 3, 5, 9, and 10 as our data, calculate the range, my largest number would be 10, my smallest would be 1, 10 minus 1 is 9, and we get to that. Okay? Now, this might be newer, and this is some of my favorite stuff in statistics because we're getting into something that people refer to as a bell curve, sometimes called a normal curve, and this relates to a lot of things. We're going to start getting into things called percentiles, standard deviations. If you've ever taken an AP test, 1, 2, 3, 4, 5 are the grades that you can get. If you've ever taken an international baccalaureate test, 1, 2, 3, 4, 5, 6, 7 are the scores that you can get where 7 is the highest. If you've ever taken the ASVAB test, which is military, there's something called a Stanine score, and a Stanine score is basically the normal curve or the bell curve broken into 9 categories. Okay, so it's just a matter of kind of putting different score amounts into different amounts. But it all comes down to really relating to what the standard deviation is. Okay, and the standard deviation and the variance are 2 things that we're going to talk about. Now I want to just kind of briefly read you about what the variance is. And if you find the variance, it's really easy to find the standard deviation because all you have to do is you have the variance, take the square root of it, you get the standard deviation. That's honestly, the hardest, all there is to about it. So, in this particular book that I have here, it says the variance. There is still another way the nature of distribution can be described. So remember, we've talked about the average, which is the mean. We've talked about the middle, which is the median. We've talked about the mode is the most occurring number. We We talked about the range, which is the highest and the lowest. We talked about skewing right and skewing left. The median has half the data above it, half below it. The mean is influenced by outliers. So if you have outliers to the right, so it's skew right, it pulls the mean to the right. If it's skew left, then it pulls the mean to the left. The median is not influenced by outliers. So this measure is the extent to which the values are spread out. There's something inherently different about the distribution of test scores like those portrayed in this example, which I'm not going to go over in this book. Let's see. So this is what we're going to aim towards. Let's try and draw something that's relatively symmetric. Can you? I realize it's not the greatest drawing. I free-handed it, but can we say that it's relatively symmetric? Is that okay? And if I do that, then I can do a few things. I can say, well, I have this, and if it's relatively symmetric where I don't have outliers pulling to the right and to the left, we can say that the mean and the median are about the same thing. So x bar and x hat are basically going to be the same thing. Okay? Now, there's a certain distance this way, which is a positive distance, and there's a certain distance this way, which is a negative distance. So you want to look at the mean on a normal curve as like 0 on a number line. And if you go to the right, it's positive. If you go to the left, it's negative. Okay, so that's where we're heading. So if I'm to the right, if it's a normal curve, so I didn't talk about this being bimodal or anything like that. I'm talking about a normal curve. We have certain information to the right, which is positive from the average, and certain information to the left that is negative from the average. And all the negative doesn't mean it's a bad thing. It just means you're to the left of it. Okay? Now, when we get into a term called percentiles, the 50th percentile is the middle of your data. And the 50th percentile, half your data is above that, and half your data is below that. This is stuff that people goof up so often. So, I speak my mind, believe it or not. I'm not this introvert all the time. I mean, I know you find it hard to believe, but, you know, it is what it is. So, when I was living in the state of Nevada at the time was ranked number 49 out of 50 on how much they were funding public education. Meaning 50 was the worst, 49 was just about as bad. And so I was at a conference, and all the math teachers were there throughout the state that could make it. And we're sitting in this huge arena at the University of Nevada Reno. I forget what it's called, but it's where they play basketball and hockey and stuff. And I'm sitting close to the front row because I learned my lesson early in life that if I sit in the front row, those who are presenting can see me. And the reason I sit in the front row is because I want that person to see me. And you can ask the other teachers, you can say, does Mr. Sturb really sit in the front row? And they're like, yeah, he's a geek, he always sits there. Like the other day, we had that all-school seminar. Where do I go? Front row. Sitting right next to Mr. Silva. Of course, he's sick and he's coughing. I'm like, you on medication? Yeah, how long? 48 hours ago, you're not contagious any longer. So I felt good about myself. Plus, it was build my immunity if I could catch anything from him. So I was kind of grateful out of it. But I sit in the front row for a number of reasons. The main reason was my very first year as a teacher. I'm like 3 days into my contract. It's like the come back to school, how you doing? Hey, what'd you do over the summer? Hey, look at the new guys. And there's like 19 new teachers at my school. 4 of us were math teachers, and there were some science teachers. Actually, one of the science teachers got married. And we're still married, which is awesome. And then from there was other teachers as well. Yeah, she teaches at Raffalo Community College now. So she's smarter than I am. I married her. So anyhow, Ed Baycheck is one of my best friends, and he had been teaching at the time about 11, 12 years, and he liked to goof around. But he was one of those guys that he could goof around and make others laugh, and then the others who laugh are the ones who are getting in trouble, and he looks like the innocent one. You guys know people like this? This is Ed. I mean, I love the guy. So we're sitting there, and I'm chatting with Ed. I'd known Ed now for 3 days, and went out and sat there and chatted with him, and he actually became my mentor teacher, and he was just a great person for me to know because he was about as sarcastic as me, if not more. Well, we're sitting there, and they have these bagels that are there for breakfast for us all. We're sitting in the back row, and there's somebody in the front who's presenting all of this information. And Ed looks at me and goes, I bet you I can put this whole bagel in my mouth. I mean, this is entertaining to me. I can listen to the guy speaking up there who I'm not really interested in, or I can watch this guy I've met and I've known for 3 days. He's a pretty cool guy. Put a whole bagel in his mouth. You got my attention. Okay, you follow me? So he takes this entire bagel, and I'm not talking about like these little, bagels. I'm talking this thing had some girth to it. So he's getting it in his mouth, and he's pushing it, and all of a sudden he goes, well, he's choking on it. What do? I start laughing. It was funny. No, it really was. Because
You could have died.
but I'm certified CPR. I mean, before he blacked out, I could have dislodged it, but I'm going to laugh at him first. Now, as this whole event's taking place, there's this other math teacher named Don Millette. Now, Don had lost it. The guy taught with puppets. He had Mr. Algebra. And he had Mr. Calculus. And he would have them on his hand when he would be teaching. And he'd be like, hey, Mr. Algebra, what do you think about this? And he'd have these voices. It was freaky. I mean, this guy should have been committed. That or a math teacher, one of the two. But he was such a goofy-looking guy. And he is wearing this jogging outfit that's like velvet. Now, you shouldn't wear this stuff, especially when you're like a 58-year-old man. Well, he got up and he's sagging them a little bit. Not where you can see his boxers in the way of it. And so we're seeing something that we don't need to see. So here's Ed, act like he's choking. And here comes Don, comes walking by with his drawers dropping down, exposing a little of his back door. So Ed's like, and points at Don. And so I'm already doing that quiet laugh, like trying to hold it in, going, I'm going to get in trouble. And then he points to Don, and I see Don, and it goes, bah! And I'm laughing like crazy. And I get a hand on my shoulder saying, Mr. Stirrup, you're dismissed for the day. We'll dock one of your sick days. This is my 3rd day of being a teacher. I haven't even had students yet. I've been asked to go home. This isn't good. So I have chosen now that I will sit in the front row because Don Millette ain't going to walk by. Ed Baycheck's not going to be choking on a bagel. And anyone else wants to goof around, it's happening behind me, and I can't see it. So that's why. So anyhow, I'm sitting in the front row. The governor is speaking in the state of Nevada. And the governor says this. We would like to get to the average amount of money being paid per student for education. So I'm listening to him speak. And I'm just going to put an arbitrary value out there. I don't remember what the values were. But Nevada at the time, let's say, was paying, each student was worth like $2,000 per kid towards the school district, which then created jobs for teachers and administrators and everybody else. That's where the money comes from. and let's say the average was $5,000 per kid, and then you got freak show places like New York that pay like, $30,000 per kid to go to school. Of course, the taxes on your house back in New York are, way through the roof. So this governor is saying, I want Nevada to get to the average of what we're paying per kid for school. Theoretically, that would then improve the educational environment of the state of Nevada. Sounds good. So then he changes his tone, and see if you can pick up on this. Once we get to the average, it's going to be fantastic. So our target, and again, these are arbitrary values, our target is to get to here. And that way we will be at the average amount of money spent or paid by the state per pupil for schools, which will improve our schools. Are you following this? Then he said we will be at the average. What happened? My hand went up. There's like 7,000 people in this place. I'm the dork with my hand up. I'm no longer laughing at Don Millette because he's not there. And Ed Bachek because he ain't there. This is like my 7th, 8th year teaching. So he keeps saying we'll be at the average. We'll be at the average. Once we get to that, we'll be at the average. My hand goes up. What do you think I said to the governor? What? It would. Why? There you go. I am increasing this to get to what this average is here. So once I get to what this average is here, this becomes a larger average. But he thought was so proud of himself that we're going to get to the average. We'll be at the average. No, actually, when we get to the average, we're still going to be behind the average because now we're adding a larger value in as part of the average and dividing by 50. And he says to me, well, how do you know that? There's math teachers only in this room and the governor. And people are laughing. Not at me, but at the governor. Oh, maybe the front row isn't the best place for me. Yeah, I know. So that's where we're heading with some of this stuff. All right, let's talk about math. Okay. So now, average, median, normal distribution means it's relatively symmetric on both sides. So if we were to take our data on this one, we have 1, 3, 5, 9, and 10. So we're going to generate what I was talking about and get into it. So it actually does relate in even though I'm a big jerk. Okay, so if I'm going to find the average, I'm going to add all those up, and I'm going to divide by 5, because 5 is the middle number, right? No, because 5 is the total number of numbers, right? So if I add all these up, I'm going to get x bar, and I'm going to find it to be 5.6. Okay? Now, I already did the work for you, so you just have to trust me on this one. And then what I want to do from here is I'm going to take those values, and I'm going to go x minus x bar, and I'm going to put it in parentheses. So x bar is the average. What do you think x is? If x bar is the average, what is x? X is 1, x is 3, x is 5, x is 9, x is 10. Okay? So, if I were to go x minus 5.6, x minus 5, or 3 minus 5.6, 5 minus 5.6, 9 minus 5.6, and 10 minus 5.6, that right there is negative 4.6. That should tell you are which direction from the average. Left. Good. This is, how much? I don't know. Negative 1.6 maybe? Negative 1.6 means we're which way from the average? Left still. 5 minus 5.6. So that's negative 0.6. Am I doing anything wrong? Other than teaching? Do what? Was there a question? I'm sorry. Okay. This should be negative 2.6? Oh boy, thank you. Thank you. All right. 9 minus 5.6. How much? 3.4? Hey, what do we know about this? It's to the right. Why is it to the right? What tells us it's to the right? It's positive. And 10 minus 5.6. How much? 4.4. So 2 of these values are to the right of the average, and 3 of them are to the left of the average. You still with me on this situation? Okay. So then, our next thing that we want to do is we want to go, what is x minus x bar quantity squared? What is the squared going to do? If I square a negative number, what happens to it? It becomes positive. Could somebody tell me what 4.6 squared is? And then I also need 2.6, 0.6. 21.16 here? Okay, and what is negative 2.6 squared, or just 2.6 squared? This is 0.36, I know that. 6.76. What is 3.4 squared, please? $11.56. And then 4.4 squared, please. 19.36. Okay, so does everybody understand how we just generated those numbers? And does everyone understand why they're positive now? Does that make sense? So the next step of this whole operation of wonderfulness is we're going to do x minus x bar quantity squared, but we're going to use the big Greek letter sigma. This in math means the summation of. And a short version of summation of is sum. And sum means add. So I need to add up those 5 values. What do I get? If I add up those 5 values, what do I get? 21.16, 6.76, 0.36, 11.56, 19.36. Henry, wake up. 59.2. So why is there only one number right there? Because I added them all up. I'm looking for the sum of a list of numbers. Okay, phone away, please. All right. So I'm going to go split screen on this. See if this works. All right. So I need to take a step back for a moment. Now, I'm going to use 2 different Greek letters. This and this. And these both mean the same thing. And what they mean is, if I'm talking about a population of people, I'm going to use this here. If I'm talking about just my sample, I'm going to use the bottom. What's the difference? Right. Okay? So, if I have a population, you could be talking about a large number of people. So we're going to use n minus 1 when we have a population. Okay? N represents the number of numbers we have. How many numbers do we have in our original list? 5. Okay? So n minus 1 would be 4. If I just have a sample, I'm going to use n. So population n minus 1, a sample n. Okay? So that's the little disclaimer to the rest of this. So when we look at our stuff, it says use 1, 5, or 1, 3, 5, 9, 10 as your data to calculate the standard deviation and variance. Up there, those numbers, 1, 3, 5, 9, 10, is it a population or is it a sample? It looks like a sample to me as well. So I'm going to divide by what? 5. Okay? So now my next thing is I want to take the summation of x minus x bar quantity squared, and I want to divide whatever that comes out to by n. So that means I'm going to take 59.2 and I'm going to divide it by 5. And 59.2 divided by 5 is how much? How much? 11.84. Okay. That is the variance. That is the variance. The very last thing I want to find up here is I want to take the square root of the summation of x minus x bar quantity squared divided by n. So that's going to be the square root of 11.84. What does that mean? What's that going to be? Square root of 11 is a little bit more than 3, less than 4. How much? How much? 3.44. So my standard deviation, we're going to refer to as S sub x. That's my standard deviation right there. Why did I label it S sub x rather than that weird looking 6 thing? Because it's a sample. Good job. Huh. Okay. Now, this is where we're going to go with this. I'm going to pull up Mr. Calculator. No, I'm not teaching with puppets. And I want to verify that we can get this information with the calculator. So if you have your calculator, please get it out. And we're going to run through this stuff real quick. All right, so using my calculator, come on over here. All right, I'm going to go stat, edit. I have information in my list. I go to the top, I hit clear, I hit the down arrow. In list 1, I'm going to put 1, 3, 5. So 1, 3, 5, 9, and 10. Seem okay so far? So what we want to do is we are going to now find the one variable statistics for this information. So I don't have to graph it necessarily. So I'm going to go back into stat. I'm going to go over to calculate, and I'm going to hit the one variable statistics. And we would like the one variable statistics. In my case, I'm using list 1. Because notice it is list 1, list 2, list 3, 4, 5, whatever list you're in. And if you hit enter, we've already done this. Well, our average is 5.6. Well, we had an average of 5.6, x bar. The summation of all of our numbers is 28. We didn't really ask for that up here at all. Okay? So if I added all these numbers together, I get 28. The summation of all of our numbers squared is 216. I didn't ask for that either. Okay? That's just information. And then we have s at x and this number 6 at x. So I'm dividing by I'm dividing by n here, and I'm dividing by n minus 1 here. So on our sample, we had 5 numbers. I divided by 5 here, but if we're saying it's population, I'm dividing by 4 here. Should these numbers be different then? When do you think these numbers don't make that much of a difference? When do you think these two numbers would be really close together? N minus 1, right now I'm going 5 minus 1, getting 4. 5 and 4 are pretty close together. What if I had 2 million pieces of data? I divided by 2 million, or 1,999,999. Is there much of a difference there? No, we're talking big numbers. So the larger number of samples we get, the closer these get together. So when you're talking about a population, you're subtracting 1 from your number of sources. When you're talking about anything else, you're going to use just n. Okay, so we got that. So then we have n equals 5. Yes, we have 5 pieces of information. our minimum value is 1. Our Q1 is 2. We'll get to that later. Our middle is 5. We didn't have to ask for that. Well, that makes sense. Our middle is the middle of that, so it's 5. Good. Our Q3 is 9.5. We're not there yet, but we're going to talk about that. It has to do with box and whiskers. Our maximum value is 10. Remember, our range was the top and the bottom, so 10 minus 1. That's going to be 9. So we can find that. Okay. So I had all that in place. So I found my standard deviation of 3.44. My standard deviation is 3.44. I verify I'm using... Oh, why did I do that? I didn't go backwards. Oh, dang it. Because TI is backwards. TI is backwards, TI is backwards, TI is backwards. Okay, 3.44 is indeed this one. TI, the Texas Instruments, they're backwards on their thing. Texas. So TI is a little bit backwards, so just remember this. Remember this on this, and I apologize, I forgot about that TI does that. When you're using your TI is always going to have these flip-flop from each other from the regular world of statistics. Okay? So be aware of that. That should, let me see, I want to start a little bit of 3.4. It's not hard. Can I go over 4 things real quick so I can get started on this? Okay. So I'm starting notes on 3.4. I'm not going to give you homework on 3.4, but I wanted to start it. Okay? There are 4 levels of measurement used in to categorize data. You have nominal, which is the lowest level, and that's like names. So you have a list: John, Becky, Sue, Paul, Fred, Kyle, Eddie. Okay, that's nominal. Okay, nominal could also be hair color. It could be ski resorts, things like that. Calculation is you're putting your data into some sort of category. You're putting it into a category. You can do it as a bar chart, or you can do it as a pie chart. Okay, ordinal. So this is the next one down. Some order differences cannot determine or be meaningless. So high school rank, a lot of times, is ordinal. If you're ranked number 56 in your graduating class from Cherry Creek High School, that means there's 55 people in front of you and probably 800 people on the other side of you. Okay, so you might be all right, but that's class rank. Order in a batting lineup where we're not worried about the 4th hitter. So think of it as just lining people up. Okay, that's ordinal. Interval, you have order data, and you compare the values. It's like ordinal, but we determine meaningful differences. There's not a starting point. The range are equally split. There's no 0. This would be like foot size, body temperature. Okay, so that's interval. And then there's ratio. That's similar to interval, but including 0. So it's like whole numbers versus counting numbers. Remember the whole numbers? You had one whole more number to add. 0. So that's what I started with that. So I just wanted to start with that. It's just basic definitions. It's recorded for you. But I would like you guys to work on worksheet 3.3. And I will check 3.3 off tomorrow for you all. Is that all right? Sound good?